Hello, everyone. You are welcome to today's session. Today's session is going to be a very brief, a very short one. Our task today is to look at the solution to the assignment that was given on trig lesson 6. So trigonometry lesson 6 assignment, that is what we are going to look at. The assignment is what you have on your screen in red. Okay, so we are told a pole and a stick stand vertically on a vertical level ground. Or yes, vertically on a level ground, I should say. Okay, that stick is 25 centimeters long and casts a shadow of length 20 centimeters. If the pole casts a shadow of length 5 meters, what is the height of the pole? If you remember in lesson 6, okay, I explained how to get a diagram from this question, okay, and proceed. So in lesson 6, we were able to extract the diagram, okay, this way, and I asked you to proceed from you using the diagram, okay, to deal with the situation to bring out, okay, the height of the pole that we are looking for. Okay, so I'm not going to spend time going through the diagram again, how we obtain the diagram. It is already in what explained in detail in the lesson 6, the concluding part of lesson 6. Okay, so you go back and watch if you have issues with how we got this. All right, okay, so again, after getting your main diagram, which is what you have here, the advice is, okay, if you are not too mature, okay, break your diagrams down or your diagram down, composite here into the simple right angle, triangle, maximum possible that you can get. And that's resulted in the two diagrams that we have here. Okay, so now we said anytime you encounter this situation, at the normal circumstance, all things being equal, you are supposed to use enlargement and similar figures. But because we are treating this one, okay, under trig, okay, I want us to use the trig concept, which at a point, okay, will lead us to the enlargement and similar figures concept. So I said, when you have this situation, your diagram, check whether you have lines, okay, common, that you can form equation based on the common line, or you have what? An angle common that you can use to form your equation. So if you look at this here, we can obviously see in these two diagrams, we have two angles common. Okay, so what do we do? Come and take the first triangle here, right angle triangle, okay, form a ratio or an equation based on the angle that we have here. And that ratio, okay, for your angle must involve the AB, which happens to be the opposite to this angle. So you use opposite and what? And what do you call it? The adjacent, which is the 500. So take note, the opposite is what we are looking for, the height of the pole. So your ratio, okay, one of them should involve that. Okay, so well, that is what I did from triangle ABC. Okay, the bigger triangle ABC, we realize that opposite adjacent, that means we have to go for the trig ratio tan. Okay, so to remember. Okay, tan involves the opposite and adjacent. So tan my theta angle here should be equal to opposite, which is the length of AB over 500. So I label this one as equation 1. Come and take my second, okay, right angle triangle. Okay, so from right angle triangle DEC, which is this one, okay, we can also say that, what do you call it? The angle here, its opposite is what? What do you call 25, and its adjacent is 20. So you use the same trig ratio that you use here, tan, okay, so that you can easily equate. So once you use tan here, when you are coming to this, you should know that obviously you are going to use tan, okay, so that you can easily equate the two. Okay, all right. So in this case, we'll say that tan theta will be equal to opposite, which is 25, over the adjacent, which is 20. So this implies that tan theta will be equal to the reduced form of this is 5 over 4. Okay, so at this point, if tan theta is equal to this, and the same tan theta is equal to that, then it means we know that equation 1 must be equal to equation 2. So that's what we have here. This will always be too short to take a line. So comma. Okay, then what do we do? Okay, now your equation 1 is this. That is what you have here should be equal to what is here.
Okay, so on that note, we are looking for AB, the length of AB. So we cross multiply or we multiply through by the 500. Okay, so that gives us the length of AB is equal to, or we make the length of AB the subject, 5 over 4 times 500. Okay, which will give us, okay, 625 or 625 centimeters. So you draw your conclusion. Therefore, okay, the height of the pole or the pole height is equal to 625 centimeters. Some of you, okay, ignored the unit. And again, when you are forming your ratio, okay, you know that this will be length over length. So this will be centimeter over centimeter. So they will always cancel. So your ratio shouldn't have any unit. The units will cancel in the long run. I'm addressing some of the concerns that I saw in your presentation. And again, okay, especially those of you who, okay, join these vacation classes, you never leave spaces between your steps. Never. Avoid doing that, leaving spaces in between your steps. Okay, so all that I'm doing here, every line must be occupied. Okay, so take note of that. If you don't get my point clearly in class, okay, our next meeting you can, okay, ask or you can send your comments, okay, or let me know by your comments on my YouTube channel. Okay, so on this note, I want to say thank you very much for your attention, and this will be it for the solution. May the good Lord continue to bless us as always.